This way I can cut the first part. Ethan, you could say no. I'm not so good at the disciplinarian part. So honestly, you turn your camera off and you just leave. That works, but it's not wise. I'm sure if you tell me you do it, I gotta write something on the absence. But yeah, the reason why you don't want to leave is because this is exciting, right? Like you just saw the previous episode of Dragon Ball Z where they introduced Frieza, and now you're going to learn why Frieza matters, right? So we introduced databases, and we learned that PSQL was something called a relational, like you sometimes see this acronym RDBMS, relational database management system, which is a mouthful, and no one really uses that term. But any database that is SQL based at this point is what's called a relational database. And there's this essential thing about relationships. So when we think about tables, we don't just care about the tables, we care about how they're related. So if I look down here, we have this idea of constraints. And constraints are a way of, when defining your table, creating a specific relationship between well, you have an ID considered your primary key. That would be the actual thing you're using to talk about things in that table. And then there might be a field within that table or a column within that table that is what is a foreign key. And you can have multiple foreign keys, but the idea is it's pointing somewhere. It's pointing to some other table's primary key. So let's draw that first, but first we'll look at the example they use. Okay, we're doing courses and professors, and we see that a professor has, a primary key, which, everything will. And then there's a table called courses, and it looks like while there's other aspects of the course, each course has a professor ID referencing that professor's table. So let's just draw that first in Excalidraw. Or I suppose we could draw it in here if we understand this well enough. I'm just saying, okay, there's something called professors. This is just, their own syntax, but, SQL would be the official thing. But every professor would have, an ID representing uniquely who they are, and a name, and then, you know what? I think we're actually going to do this in Excalidraw just because you can actually draw the relationships a little better. So I'm going to make this first table professors. And like any table, you're going to have these different columns. So what are some columns that make sense for a professor?
Their courses?
Yeah, kind of. That's every professor is going to have a course, but we don't kind of it ends up being tricky in that, like, this is kind of the core point, which is why it's good you asked that. Like, if we were thinking of this in Python, we would say, like, okay, maybe every professor has a name, and maybe every professor, well, because this is a database, everyone's going to have an ID. And maybe that ID would be, let's say we were starting to create one, we would say, like, well, every ID is, the ID is going to be a number like 0 or 1, and the professor's name is going to be, you guessed it, Jason Momoa. He could be an acting teacher, I bet. And then you might say courses. Well, of course, like, they teach courses, right? And what you kind of want to do, what's natural to think about it in programming languages, is you want to say, like, well, courses is going to be a list of courses, and it's going to be, course called calculus and a course called acting 101. Okay, whatever it is. You want it to be something like this, but that's not actually how you end up doing it, because we want to think of these things as separate things, and then we worry about connecting them through this idea of relationships. So instead of doing something like this, we might say, well, okay, we have these different classes. So let's forget about this for now. Let's say a professor just has a name. But then we're also going to have a totally different table. Let me move these out of the way. And that table is going to be called courses. And it's going to have its own things in there. So it's going to have an ID, like one, or, let's make it so there's at least 2 classes. So every course is going to have an ID, and it doesn't really matter what that ID, it just matters that it's unique. And maybe every course has a, would you call it a name? What would you call the course's like title?
Just title.
Title? All right. So we'll say title, and this one is going to be calculus, and this one's going to be acting 101. Okay. But now the question is like, how are these related? Okay, so let's say we have some system where every course has exactly one professor. You can't have a course with more than one professor. Every course has one professor. So at that point, the question is, where do we want to do the reference? As in, if we want to, like, we have this list of professors, we could have something where we say, there's going to be a third column, which, this is our primary key. So whatever is that main one, we call that in big letters, primary key. And then what I'm about to do here would be an example of a foreign key. So the primary key represents what a unique individual or a unique entry in this table is. A foreign key means for a given row, what something it points to. And while every row has to have exactly one primary key, every row could have 0 to as many as you want foreign keys, because it just means you're pointing somewhere. You broke up your data so that instead of saying the whole address there, you say, professor's address or professor's, banking info or whatever it is that lives in another table. But in this case, we're saying, okay, we have something called course ID, right? Let's make that medium. So you might want to do something like this. It's tempting. But what would we actually put there? Like, let's say Jason Momoa teaches both of these. Then we would say, okay, well, Jason Momoa teaches calculus. And then we might say, okay, well, actually, Jason Momoa teaches other classes, so maybe he appears twice in this database. So we would say something like, we have another entry, and now this entry, because it's a different entry, has ID 2, still has the name Jason Momoa, but he teaches course 2. So this isn't great because they're the same Jason Momoa, and this table is called professors. This table is just supposed to represent professors. There's not 2 professors named Jason Momoa. We did something wrong. So we're going to take that out, and we're actually going to say we don't have a foreign key for that. I guess I'm going to move. Yeah, okay. We don't have another thing here. We don't have course ID. Instead, in courses, well, we know that every course has exactly one professor. So for each course, we're going to say something like professor ID. And then here we could say, okay, this has professor 1. And we'll see in a second, I might be able to say like, well, every professor teaches exactly one class, and every class is taught by a unique professor. That's called one-to-one, but that's pretty rare. The classic example of that is students and lockers. But when you think about that, like how rare is that for every, for every person, there's exactly one thing and it's unique, as opposed to, a system where you have courses and the courses can point to different professors. So I could have that course 1, which is calculus and is taught by Jason Momoa. And I could say course 2, course 2 acting 101, that's taught by Gal Gadot. But there's no reason it has to be that way. It could just as well be that Jason Momoa teaches both of those classes, and that's what we would call one-to-many. So I think the arrows here would be something like, for every, that's where this becomes useful. Where was it? The what were we? The database thing, right? So if I try and copy this over, I have like a primary key, professors with an ID of integer, and a name. So this is close enough right now. Oops. Okay, looks like we have to start over anyways. And I'll just take these out for right now. So I had a table like professors and a table like courses, right? And what we said is that for every professor, that professor has just a regular ID. And in this case, we'll just say it's an integer because that's, you know, this generalized thing. And that's its primary key. And then it also, every professor also has a name, and we'll just write string in there for now because that's basically what it is. And that's all there is to a professor. But now when we look at our courses, they also have an ID that's a primary key. And then they have a title. So let's add that in there. We'll say title. And we'll say string because it doesn't really matter. But then finally, we're going to say, okay, professor ID. And that should be an integer, but it's like a foreign key. I don't know that this recognizes that. Yeah, I don't really know this this syntax too much, but I know that I can do this, and then I could say, okay, we're going to say that there's a reference here, and the reference is saying that for every course, for every course, it should have a professor ID, and that should link up to professors tables.id. And that's the relationship is telling us now is that there's exactly one professor, so the one is here per course, but this could be multiple. So one professor can teach multiple courses. Obviously, different professors can teach different courses, but there's no reason that one professor can't teach like two courses. That's what this many to one thing means. So that is the most essential one. Let's talk about that and break it down. Like, let's ask as many questions as we can about this idea of, you know, standard many to one relationship. And then once we do that, let's do it in SQL.
Is this the most common relationship you're going to have between tables?
More, I mean, there's only three types, as we'll get to. There's one-to-one, which is like student to locker. You know, two students cannot share a locker. Two lockers cannot be, like, every student has a unique locker. And then there's this one-to-many, which says that you have, you know, classes, but each class has one professor. But the same professor can do multiple classes. But then there's also many-to-many, and that would be more like what it actually is, which is you could have some classes that are taught by one professor, but maybe you have some classes that are taught by many professors, right? So many classes can be taught by many professors, and that can be kind of confusing, where it can be like, okay, well, we have the course called calculus that's taught by both Jason Momoa and Gal Gadot, but then we have a course called Acting 101, and that's taught by Jason Momoa, but also I can't think of any actors. The Rock. These are literally the only ones I can think of, and that's not even his name. But right, you have that many to many relationship, and we haven't gotten to that yet because it's a little more complex than the one to many case. Okay, I'll look at the chat quick. Yep, Amber Heard. Good point. My favorite actress. I like John Hamm. Okay, I'll mention John Hamm next time. Okay, so let's actually do this in SQL now. So if I open up my SQL stuff. Let's see, I should, so if I open up SQL here and I do ls, I made this file called constraints.sql, and we're just going to use that to keep track of our stuff. So if I looked in my actual tables right now, I could say, you know, sudo -u, the user Postgres. And now once I'm the user Postgres, I could say PSQL. And then specifically, I want to go into a table I already created called, or a database already created called IMDb. So I had this really cool idea this morning about making some kind of internet movie database. So I started the project, and I'm sure I'll have like a fair amount of data eventually. But for right now, I believe I only have, let's see, if I do /DT, that's going to tell me I have two tables, actors and films. Let's say select star from actors. I'll see all my actors. And I'll do select star from films. There they are. But I probably don't want to do it all in here. So I might as well make this like, you know, file here where I run things. So let's just do this all from scratch first, where I'll say like, you know, drop table if exists actors. And then after that, we say create table actors, and we define it. And then we'll do the same thing for films. And I'd say to start, let's think about, to start, let's just put some data in there. But because we're doing it this way, we can change what they actually look like over time, what the actual schema is. So to begin with, all I did was say, you know, each actor is going to have an ID, and the ID is going to be serial, not null. Do I have that right? Is that, I guess I could do lowercase serial. So just so you know, SQL does not care about uppercase versus lowercase. You could do like create. The only reason people do that is because it's a nice way of distinguishing between SQL keywords and things you're writing yourself. So like actors is like almost like a variable, whereas not null or like built in, create table is built in. And then I guess for data types, people tend to not capitalize it. So there's the ID, and then there's the name, and let's say that's varchar 255. Let's say that also can't be null. And then also for films, we'll just say they have an ID, same deal. We'll just have a title, same thing, not too complex. Okay, and then how about, so what do I write now? Like, does anyone want to finish this off for me? If I want to put some stuff in there, what's the command I want? So these are my schemas. How do I add some things to these tables?
You go into Postgres? You said you want to add stuff to it?
Yeah. Well, I'm going to run this whole thing. So like, what are the commands I want?
I guess, I don't know if it will be the same one, but you like make the seed where you put like insert into.
Yeah, no, it's exactly the same. As in, all I'm going to be doing is running this as if it was in PSQL. The only reason to make a script is so that you like maintain it and you can see it while you're working on it. So yeah, we'll say insert into, and then where do we want to insert into?
To whatever you want to add to. So which table are you adding to right now?
Yeah, but we want the table. So let's say we're inserting into actors. And then
ID.
Yeah, then we want to open up some parentheses and say what we're inserting into actors. So there's ways to eventually make it like good defaults or to auto increment, but for now we'll just do it all manually. So we say the ID and the name, and we're gonna, what are we inserting with ID and name? We're gonna insert some values, and we'll just say, you know, 1 and Jason Momoa. And then maybe we'll do that again for our film. And it'll be same thing where we have an ID and we have a title, And we'll also just start with 1, and the title will be The Fast and the Furious. Cool. So I don't think I put semicolons in there. That's going to complain if I don't have those in there. So now I'm going to come back here. I'm going to exit out of this, and by running this file, so I'm going to say psql imdb, but because I'm in the folder where this constraints.sql thing is, I can run that file. And now that I've done that, if I go back into PSQL and I look at my actors, I just have 1, and I look at my films, I just have 1. So the question now is, if we have a system like this, let's say we want to make it so that, obviously in reality, there can be multiple actors to a film, and multiple films can be associated with a given actor. So that's kind of a complex relationship. For now, let's say every film, we want to keep track of who, let's just say like who the number 1 person on the call sheet is, like the main actor according to the movie. So we're only gonna have 1 of those. Where do we want to put that? So every film has like 1 lead actor.
Would
Oh,
that
people
be a foreign key?
What was that?
Would that be a foreign key in the films table?
It would be, yeah. So I guess looking back here now, people are mentioning I should actually use this idea of primary key. So you're right. It just establishes that that has to be unique. Otherwise, you could add 2 things with the same ID. So, and I think primary key assumes not null. So I think we can do that. Okay, so it looks like in SQL, there's a way to do it where we just like automatically link it up. So I could just say something like in the film, I would say, okay, every film has a lead actor, and that lead actor, it's actually going to be a foreign key. So it's going to, the lead actor is going to have type serial, I guess. And I think you can. So there's different ways to accomplish this, but I don't think we use any kind of foreign key wording. Like we could just say like, okay, the lead actor, it's serial and it's not null. And I would say like lead actor ID because we want to know that we're pointing to something in the actors table. And then in that case, I could say like insert into actors ID name, nothing has to change there. Insert into films ID title. Okay, also lead actor ID. And then in there, I would say 1 because I'm saying, okay, this is my first film. It's called Fast and the Furious, and it stars whatever actor has ID 1. So if I do this, I think this on its own works in that I can run that code again. And if I go into IMDb and I say select from films and select from actors, there is that connection there. It is saying, okay, lead actor, look it up there. But I think for SQL stuff that we're going to learn to recognize it, we're going to want to say something like this, where we don't just say, lead actor ID, serial integer, whatever it is. We actually want to say references and then what it references. So in here, we could say it's serial. And then I guess we don't have to say not null because it has to link up to a specific existing thing. So it's going to reference. And what does it reference? The table and then the column in the table. So our table is actors and the column is ID. And so this should work as well now. And based on what we've seen, there's no difference yet. Films. Okay, yeah, but we have that lead actor ID. So where it gets interesting is that we're gonna not look at this one yet. Oh, I don't think we have it in here. Give me a second. What we want to do, it's what's called a join. Like, let's say we want to we don't just want to get, all the actors, we want to get the, the lead actor for a given film. And I guess to make this clearer, maybe we would add a few more things in there. So like, what's another actor we could think of?
Anthony Hopkins.
Okay, Anthony Hopkins. And what is a film or two that he is in?
Silence of the Lambs.
Okay, and is he only in Silence of the Lambs, or is he in another movie?
He's in Zorro.
Is he? That's fun. He wasn't Zorro, was he?
Yeah, he was old Zorro.
Oh, yeah, you're right. Yeah, he was old Zorro. Okay, so we're gonna run that again. Doesn't seem to like that. Why not? This is actually a whole thing with dropping things where it's getting upset because it wants me. The problem is that it's trying to drop, when it tries to drop films, it says, or when it tries to drop actors, it says there's this table called films that relies on me. So I can't drop actors until you drop films. I think the easiest way around this for right now is we just define them in a different order. So I think this will now work. Yep. Oh, and it didn't like something. It said duplicate key value violates unique constraint for actors.
You're entering the same ID home value.
That's the problem, right? Yeah, very good point. So yeah, I mean, that's kind of the benefit of SQL, that it's so it won't let you add things unless it actually makes sense. And with actors too, that doesn't seem like that. I think I actually need to do this drop cascade thing, so I'll just look that up quick. So all that is that once you start setting up relationships, it doesn't like you dropping a table if it, there's something it relates to. And I believe that just involves adding a single word. So instead of just saying drop table something, we say drop table cascade. Okay, so let's try that. I'll put these back in the order they were. And then I'll just add it to both of them. I don't see how it could hurt. So drop table, if it exists, actors cascade. Is that what I want? Doesn't seem to be recognizing it as a keyword. Doesn't seem promising.
It doesn't look like it had the if exists. It's just drop table actors cascade. I don't know if that would help.
Looks like parameters if exists, name, cascade. So drop table, if it exists, the name of the table. It looks like I should be able to add cascade there. Well, maybe it just doesn't highlight it. But let's see. Oops. Let's see if I try run that again. Drop cascades. Okay, I think that is all good now. So I'm going to go back in there and I'll see what I have. These are my films and these are my actors. So I have 2 actors and then I have 3 films, and there's a lead actor for each film, and it could be a duplicate in terms of the actor. But what I want to do now is, like, how might I say, I know how to say, get all the films, but how do I say get all the films and their lead actors without having it say, lead actor ID? Because that doesn't really that's not very useful to me as a person. I kind of want to join these tables together, right? I want to say, get all the films, but then wherever I said lead actor ID, actually fill in all the details of whatever that points to. So in SQL, that's called a join. So the first thing we're going to do is just like, normal, we're going to say select star from actors, or actually select star from films. And if we just ran that, that's just going to get us all of our films. But there's things I can add where if I say select star from films, I could also add a where clause. And we've seen this before where I could say like where title equals Zorro. How about that? I didn't even spell Zorro right. So I think this will get me just Zorro. And then I could just as well say, where the lead actor's ID is equal to 2. Now we'll give you all the films Anthony Hopkins is in, but I wouldn't see that they're, I don't, what does 2 mean, right? So what I actually want to do is say something like select star from films where, and then in the where clause, I say where.
I think in your from statement, you also have to include the other table that you're trying to pull
Yeah,
from.
you're saying select star from both. No, I think I'm more used to this thing where you call it a join. So we say select star from films to get everything from films.
Inner join.
What was that?
Yeah, it's like select star from films, inner join,
Yeah.
actors.
Yeah, so I'm realizing, right, I don't want a where there, I want a join. And in this case, I could say inner join, but there's other ones. We'll look those up in a second, but they basically have to do with null. So there's different types of joins, but the different types of joins are about what to do when something is null. And an inner join will get rid of anything that's null. So if I had a film whose lead actor ID was null, that film wouldn't look up its lead actor ID. Okay, so I'm doing select star from films inner join. And what do I want to join on? Well, I want to join it with another table. And that other table I want to join it with is called actors. But that's not enough. I actually have to say on. Then I have to say what the relationship is between films and actors. So I'll say films dot lead actor ID. So within my films schema, which I can open up here, within my films schema, I have something called lead actor ID, and it references actors. So I want to say join films from here dot lead actor ID with I guess we use an equal for that. So whatever film.lead actors ID is, I want you to match it with this table actors, which we mention here in the inner join. It's .id. So it has its own .id, and we want to match those two up. Now when I run that, now it combined all of it, right? So it combined the ID from the film, the title from the film, the lead actor ID from the film, the ID from the actor, and the name of the actor. So that's a join. It's just joining those two things together on that hinge of a matching lead actor ID to ID. But in general, you're probably going to want to clean that up a little. So you do care about the IDs for the sake of that. But what you probably would want to do is in here, just say something like, well, I want to know the title. I don't actually care about the ID of the film. And I want to know the name of the lead actor. And now if I do that, it's able to do it. It's combining is there a, did I do that syntax poorly? For the select?
When you select, you may need to do the title of the table dot
Yeah, I see. Yeah.
title.
Right. So I think what it wants more than that is, well, no, I think if I get rid of that, if I do this, that works, right? So now it knows title and name are the column names. But just because it could be ambiguous, as in it could be that, the name of the movie is called name and the name of the actor is called name. So you could actually fill those in and say films.title and actors.name. But that results in the same thing. So now I've found all the titles matching to all the names for my whole thing. But in reality, I would probably do this where, like, you can kind of read SQL in steps. So like this first part is saying, grab films.title and actors.name, but from where? And we start with from films, but this kind of whole thing gets combined. So from films, inner join actors on whatever, that itself is this inner big table. And then I'm saying just get the title and the name from that big table. But if I wanted to, from there, I could add a where, and maybe in that where I would say where, I can be explicit if I want, where I say like where actors.name is equal to, and in this case, Anthony Hopkins. Oh, and I did that thing again that I always do, where I do double quotes. So now I'm saying, right. So now I'm saying, like, I want to get all the films where Anthony Hopkins is the lead. But I use the join table internally to kind of combine it into a larger thing. So if we draw that out a little better, let's see what that actually might look like in real time. So this is basically the same thing, professors and courses, as what we did with films and lead actors. So when I write, like, ignore the first part about the select, let's just start with from films. So the first thing I do is I come in here and I say from courses. I start with courses. And it's like this whole thing here was grabbed. So from courses is kind of being built up. This whole thing here was grabbed. And then I say from courses, well, I'm not done. I want to inner join that. So I'll just do this all in one line because it doesn't actually matter, but I want to inner join that with professors. And how do I want to join it on? And can anyone tell me what is going to be the relationship in this between courses and professors? How do I associate courses with professors?
Professor ID.
Yeah, so what would I write here?
Courses dot professor underscore ID equals professors, and then however you have it written, I believe like dot ID.
Exactly, yeah. So generally when you have one of these, one of them is going to look like something dot, name of the table underscore ID, and the next thing is going to be equal to name of the table dot ID, because the primary key is usually called ID. So now that I've done this, join, internally, this now looks like this, where it took the whole course and then it didn't remove it. It took the professor ID and it matched the professor ID up to the up to what's here. So in this case, they're both one, so they're both Jason Momoa. And it's sort of like this. Like if I can make this larger. Line it up. So yeah, it's sort of like this now, where after I do that join, everything from both tables is in there, and they just line up based on those matching IDs. So, there's like a one-to-one between these two. And by one-to-one, I just mean they match. I'm not saying the one-to-one versus one-to-many idea. Okay, Chris, you're raising your hand?
Yeah, I just had a question about so the inner join joins all the things that are similar. The outer join joins stuff that's will also include the stuff that's not similar. Where does it just stuff it in the bottom or
No. So the idea of joins, there's a couple type of joins in SQL, and they're associated with the concept of a Venn diagram. So the idea of a Venn diagram is like something could be in A but not in B. Something can be, you know, in A and in B. And there's all these different cases you might want to worry about in regards to whether something is null. So like inner join is this one over here where it says if the thing is both in A and in B, then it'll end up in that final table. Whereas you could have some things where you say, let's say, you know, I'm trying to match courses to professors. So courses is A and professors is B. I could, that left join looks like it's something like this, where I would say, okay, well, I have professors and then I have courses. Well, what if I had a course and there wasn't a not null constraint? So let's say I had a course called, you know, whatever, like CS 101. And that one just has like null here, as in there is no professor ID. In the case of a left join, it would say, okay, well, as long as it's in the left side of the table, you said you wanted all the courses, so I'll include everything in the right side of the table and just have nulls there. Whereas the inner join says only if the thing exists on the left side do I actually match it to something on the right side. I wouldn't worry too much about it right now. It really only matters in terms of behavior for null, because eventually that does become a thing where, like, you know, not everything is going to be filled in. And what do you want to do in that case? It turns out there's 7 options for what can happen, and they're all different. They're left join, right join, inner join. I would have to see the difference for, I think it's just the order in which you're joining them, and then full outer join is another thing. But yeah, we'll come back to that later if we find it necessary. Okay, any other questions about the basic thing here? Shouldn't say basic. It is the thing that makes a relational database unique, but it's not really basic. It kind of takes a fair amount getting used to, just the essentials of how you want to, you know, link things up to each other, and then how you join them together for the sake of querying. If I were to finish this up here, it would look like, you know, at the top, we would actually have a select, you know, something, and select star would be what we actually got. But in reality, we might want to have something like courses.id, courses.title, and then professors.name. And then what that would give us at the end would be something that looks like that. I guess I can shrink this a little if I can, we'll see. Close enough. But yeah, that's how a table is kind of built up in steps. Okay, so I see we've been going for at least 50 minutes. We should take like a 10-minute break now. And when we come back, we'll cover any questions, but we'll also cover this idea of different types of relationships. So I think using these would be a good way to try it out, where like this is pretty classic, like a car company can have, I guess, a car company and a car model like, Lexus ES350, you can't have Mercedes ES350. I feel like that's not even true. But I don't know, we'll do students and lockers for that one. And then most things are one-to-many. So like, but a doctor can have multiple patients. I guess in this world, doctor can have multiple patients, but a patient only has one primary care doctor. But in reality, most things end up being many-to-many. Many doctors or doctors have many patients, but patients themselves have multiple doctors. And that's the big one we'll look into how you actually implement that when we come back. So we're going to be back in about 15 minutes. We'll give you 15 minutes. Come back 10:15, slightly before. Cool. Okay, we're coming back. Okay. So the main thing we want to talk about now, like we talked a bit about one-to-many. And I guess before moving on, any questions or let's talk as much as we can about one-to-many because it is the classic case, and we can do that both in Excalidraw or in our actual SQL. Any questions on one-to-many? Okay. Well, if not, just to review, one-to-many can be a situation like, for every course, there's a single professor. So many courses, but only one professor. In this case, I have something like I have actors and we have films, and we just decided that, instead of saying all actors in a film, we have the lead actor. And that's also one-to-many because for many films, there's one lead actor. And I changed this around a little because I saw that, this is the more common way PSQL does it in their own docs. So I thought I would do it this way for the sake of the other relationships, but this is identical to what we did before. It's just more explicit where right here we're saying, for films, there's an ID, there's a title, there's a lead actor ID, but we don't actually set up the relationship between lead actor ID and actors here. We actually, on the next line, or at the end of all of them, we say constraint, and then we name the constraint. So this FK here is saying, we have something called foreign key lead actor. We're just giving it a name that represents a foreign key, and we say that lead actor ID is that foreign key, and it references actor's ID. So this is just a way of splitting it up so that it's you can be a little more explicit about what the constraints are, because I believe what we did before was just this, or something like that, but it seems like PSQL likes this approach where you do constraints after. So any questions on that? Just like we have actors and we have films and we're able to relate them to each other in this one-to-many fashion. So the next thing we might care about, yeah, anyone?
Yes, can you elaborate on a constraint a little bit? I'm kind of confused. How is that related to foreign keys? reference
Yeah,
ID?
so I think it's just an alternative to, like, if we look here in these docs, we seem to do it like this. Where we say, like, you know, there's something called professor ID, it has type integer, and then it references professor ID. So it just seems like this is a more explicit way to do it, where you actually say there's a constraint, and that constraint has a name. Because you might want to, you know, reference it by name at some point. Like there's this idea that you're naming called FK course professors. It is a foreign key, and what it looks up is professor ID, and it references professor's ID. I think it's just it's a bit more of an explicit way to do it that kind of separates the data itself from this constraint on the data. And that seems to be the way that some of the other relationships are done. So I thought it would be good to do it that way.
Okay. So basically primary key, foreign key, they're all constraints, correct?
Yeah, exactly. So if we say primary key, and not null is also a type of constraint, as in primary key is saying this thing has to be unique. You can't have two IDs with the same value. And we're saying there's only going to be one of these. There can only be one primary key. And not null is a constraint saying it has to be, you know, this title can't be null. But then there's this keyword constraint that is used for setting up relationships between a foreign key, where there's nothing in here that makes lead actor ID know that it's, you know, it could hold a number. It could just simply hold a number. But this is where we're saying there's a specific constraint where we're associating lead actor ID as a foreign key that references a different table called actors and its column ID. And then we give that constraint a name, I think simply because somewhere in PSQL, all this stuff is being tracked. So if we want to like update the nature of that constraint, we might be able to like look at that specific name and say, oh, that's different now. I'm not really sure. I'm just copying the syntax I'm seeing on the website.
Makes sense. Thank you.
How are in the future, I'm assuming we're going to use this constraint with to help with like table something, like what are you going to use the constraint for? Like why are you including it?
I'm including it so that there's this relationship between this foreign key and what it references, because this is going to allow SQL to do joins on it, or PSQL to do joins on it, because it knows there's that relationship. I believe. I hear what you're saying, that I think if I don't include this stuff, the way I was doing joins, I was being explicit, so it would match them up anyways. But this makes it, I think, so that if you try and like add, I think that's it actually. Like if I were to try and add a film at this point, so everything here works right now. But let's say I were to try to add a film, and I were to say that this film, it's going to have value 4. Its title is going to be The Shining. Okay. And then I'm going to say its lead actor ID is 44. I'm just going to say, well, there's, you know, something called 44. I believe the nature of this constraint, if I didn't have this, it would say, oh, that's not null. That's a number. Cool. But because of this constraint, it's going to actually look it up and say, when you tried adding that, you said lead actor ID references an actor. Well, there is no actor with value 44. So I'm not going to let you add that. So let's actually try and see what happens. Yeah, so right here it says insert or update on tables film violates foreign key constraint. This is probably why you name it FK lead actor, because the key where lead actor ID equals 44 is not present in table actors. So that's why it's literally a constraint. It says if you try and add something, it won't work. And if we took that out, let's say we comment that out and we do this, this should now not throw any errors. Oh, oops, I didn't do the right one. So right here, if I comment that out and I do this again, I believe everything works. And if we went in there now and we said something like select star from films, we would see that, we have all these films. But now if I try and do that join type thing where I say like, okay, get the, what's one we did a while ago? I'm saying, for every actor, I guess I want to do it more like this. I'm saying for every film, go to all the films. And for right now, I'll just say I want to know the film's title. But I guess I'm also going to want to know not just the film's title, but also the actor involved. So I'll say actors.name, right? Yeah. So those are the two columns I want. So I'm saying from films, and then I say on, I don't have that syntax right. I say inner join. Oops. I say inner join, and I want to inner join on actors. So starting from films, I inner join on actors, and I inner join on something where I say films where we have this lead actor ID. And I want it to be equal to actors.id. So if I do this, it's going to show me all of the films, but this is where that inner outer join thing matters, because in this case, when I look at all the films, I see I have a film here called The Shining with a lead actor ID, but because it couldn't find it, it just threw that out based on the join I wrote. But if I said not inner join, but I think it's full outer join or something, now it actually includes it, but it includes The Shining with, lead actor no. And that constraint is there because even though we could do joins without it, the constraint is there to say, I don't want to get into a situation where there could be a film with a lead actor that doesn't actually exist. And so this constraint is there to ensure that when you're adding things, because of this line over here, when we're adding things, it doesn't like that actor doesn't exist. So it didn't actually add that movie to the films table.
That was exactly what I was asking. Thank you.
All right, great, awesome. Any other questions about the one-to-many thing right now? Okay, if not, the next thing we're going to do is just talk about one-to-one. So very often lockers is the example used. It's hard to think of other examples, but it is worth teaching just so you know all the relationships. So in one-to-many, it's a relationship where one record from table A may be referenced by one or more records from table B. So if table A is actors, then you might have table B be films, and multiple films can have the same lead actor. So multiple things in table B can point to the same thing in table A. And if we show that in Excalidraw, it's like this, where we have professors and we have courses. So the course Calculus is taught by Jason Momoa. The course Acting 1 is also taught by Jason Momoa. That's one-to-many, because for one course, or rather for every course, there could be, I guess I don't know why it's called one-to-many exactly, but it's this relationship where there's no unique constraint. So no matter how many courses you have, they don't all need to be taught by unique professors. They just need to be taught by a professor. So it's this column here, which could be many. Meaning that, you're able, if you ran this, you would find that there were many classes taught by Jason Momoa, who is only one actor. But the one-to-one relationship is one where at most one record from table A can ever be referenced by a record from table B. So we're going to do that here in terms of lockers. So here I just created a table called lockers, and I said it has a primary key like usual. It has a combo, so just the combo on the lock, which I made 6 characters. And then I said it has an actor ID, which is not null. And I'm saying that that actor ID follows this constraint, which we're naming foreign key actor, which says there's a foreign key called actor ID, the one right here, and it references actor's ID. So that's all I've done right now. And you'll notice here, I can have it something like this, where I'm saying, if we ignore the film stuff, maybe we'll move this up. I'm saying, okay, there's 2 actors, one named Jason Momoa, one named Anthony Hopkins, and then there's 2 lockers, one with locker number 10, 44, 24, one with locker number 40, 12, 40. And the first locker belongs to Jason Momoa, and the second belongs to Anthony Hopkins. So if I run that now, I think everything worked besides this, right? It doesn't like that one. I'll just say one of those people was in The Shining, even though they weren't. Okay, so this works now. And if I go into T-SQL, go into my IMDb, I have this thing called lockers in there. So I can say select star from lockers. And I see that, you know, these are my lockers, and I could also say the same for my actors. And just as a exercise, let's write combining them. So let's say we want to see the combo for every actor. How might we do that from scratch?
Would you select combo?
So select, and then what do I want to do right after select?
Would it be actors and combo, or sorry, maybe I'm thinking of that wrong.
You can
So
do
it'd be select combo.
Yeah, name or combo, whichever one.
Yeah. So right after the select, right, we just want the name. We want the rows. So because they're totally unique, we could just say name and combo. We don't need to be explicit about like lockers.combo, actors.name. And then we say from, and then the from, we just choose one table. So which table do we want to start with?
Actors.
Well, I think
Lockers,
actually,
right?
yeah, it might be what?
Lockers.
I think it
lockers
could
table?
be either. So like the classic thing would be to say start with the thing that has the foreign key in it, but I think it actually works either way, where I could say select name combo from actors, because that from is being immediately combined with this join. So we're going to interjoin it with lockers, and then on is where we say the relationship. So I don't think the order of which is from and which is the interjoin matters. I'm going to say actors dot ID is identical to lockers dot actor ID. And that should be enough. And that's you know, the name combo relationship. But what if we wanted a situation where we said like, well, you can't have it where a given actor could have 2 different lockers. And let's say I tried to do this where I said, okay, well, you know, this is the first entry in lockers and it relates to Jason Momoa. This is the second entry in lockers and it relates to Anthony Hopkins. Well, actually, they're both owned by Jason Momoa. So if I exit out and I run this, and then I go back in there, now if I try and look at this, I see that Jason Momoa owns 2 lockers. So the idea of one-to-one is, how do you prevent that? How do you prevent it where Jason Momoa can own more than 1 locker? Because that would be the end of the world, right? So basically, how do you make it so the nature of this relationship is that for every actor, there's exactly one locker, but also for every locker, there's exactly one actor, because the first case is true with one-to-many. For every actor, there's exactly one locker. It's just that, or sorry, for every locker, there's exactly one actor, but it could be the same actor multiple times, which means multiple lockers are owned by a single actor. So if we want that one-to-one thing, we're saying a single locker can only be owned by one actor. And
You
yeah.
constraints?
Yeah, exactly. So if we look in here, we'll see that it's pretty straightforward. We just add this unique thing. So we don't even do it in the constraint itself, I don't believe. We just say it here where we say like, so we have our lockers table. I'm saying, okay, well, there's an actor's ID, it can't be null, but also it has to be unique. So for everything in this lockers table, the actor's ID has to be a different actor ID than for every other row in the table. And I believe that's all we have to do, adding unique like that. And now when we do this, that constraint is actually going to blow up, and it's going to say duplicate key value violates unique constraint lockers actor ID key. It already exists. So when I tried to do this second one, it said, hey, like it didn't mess up for the first one. It's the second one that it said, we already saw there's already a row in here that has that actor ID, and we don't allow that. So yeah, that's one-to-one. And let's hover on that until we feel satisfied. But the truth is it's just good to know about, but so few relationships are actually like that.
Sorry, I got a little confused with the unique. Can you kind of explain the unique again, what exactly the unique
Yeah.
does? It makes it so that it can do multiple, or that it cannot. I got a little
Well,
confused there.
think of it like this. The unique thing doesn't even know about the constraint yet. It's just that when we have the lockers, I guess in this case, it's like, imagine that it's professor ID that we want to make unique. So we're saying every time you add something to courses, professor ID has to be unique. So the first time we add courses, it has ID of 1, title calculus, and then professor ID is 1, and that passes the unique test. The second time we try and insert something, we say, okay, this one has ID 2, it has title acting 101, it's also taught by that professor, it has value 1. This unique thing will somehow keep track of every value that's ever been in this column. And if any row already has that value, it won't let you add it. And just so you know,
and the unique just kind of bypasses that.
What?
I said sorry. So the unique property kind of bypass or constraint
Exactly.
breaks that constraint.
Exactly.
Okay.
But just so you understand, unique is not only like you could use unique even if it wasn't a foreign key constraint type of thing. So it would work just as well if I said drop table if exists letters, let's say, like letters in the alphabet. And then I'm going to say create table letters, and just because it's actually in a database, I will give it an ID and make that the primary key. But then I'm going to say each letter has, a value. We'll just call it value, and it'll be varchar of 1 because it represents a single character. And then I'm not even going to say not null. I'm not going to say unique. That's what I'll give it. Okay, that's the whole thing. And then let's say at the bottom here, or right after this, why not? I'm just going to start inserting into this. I'll say insert into letters, ID, and value. And the values are, let's say the first one is going to be A. And maybe we'll do another one that's like capital A. And then another one that's like B. And these have to be unique keys because that's how IDs work. We run this now. I things should work, not that one. So let's fix that one for now. Okay, and now if I go in there, I can say select star from letters. And those are all my letters, right? But note that I could also just add another letter where I say like, okay, well, we actually have B twice. That's fine, right? So I'll run that again. My constraints. Oh, sorry, I need to change the ID. So I do the constraints and I go back in here and I see my letters. Yeah, so I have two things with the value B. Now, all I have to do is add unique here. And now it's not going to be okay with that. Now, and because of how I wrote it, I didn't write not null. So I could write something like that and just write like null, and that'll be in there too. But now it's actually going to blow up when this happens. So if I try this out. At a certain point, it says duplicate key value violates unique constraint letters value. So unique is being used to do something with like, you know, relationship type stuff, but it's not uniquely about relationships. It's just something that says nothing, you can't have two rows that share the same content for this one spot. Cool. So any
Sorry, I got one more stupid question. Just with the foreign keys and primary keys. So a foreign key is not a primary key in another like area, right?
No, it is. So that's
It is? Okay.
exactly. So that's what makes it a foreign key. Is in the primary key means this refers to this definitely refers to a totally unique professor in this table. In the courses, this is like this is also a primary key. So for the courses table, ID is its primary key, but it has this thing called professor underscore ID that is also a key, but it's not the primary key. It doesn't represent something unique. It's not a unique row of courses. It's just a value that is in courses that it's foreign because it points to a different primary key. So it's like, there's this relationship happening here where for every foreign key, it's pointing to some, I guess let's just do it here. For every foreign key, it's pointing to something else's primary key.
Okay. Oh, all right. So sorry, now I have another stupid question. All right. So if the foreign key is not something we assign, and if it's in that position, do we ever like I'm thinking like a data tree where we have like leaves? Is there ever a point to where we have multiple tables that don't have really foreign keys that point to anything?
I'm not positive I understand your question.
I guess I'm thinking like we have a primary key and then that primary key on the next table is the foreign key. But do we have tables like will that always be the case?
No, I see what you're saying.
Like do we have
like basically
yeah, can we have
every course has a primary key ID and it has a foreign key professor ID. That foreign key professor ID in some sense points to the primary key of the professors, but professor, it doesn't point anywhere else. Like it's sort of like a leaf. It, you know, professor is its own thing. But just like a tree, you can definitely have massive relationships where you have, you know, something like students, and every student, you know, maybe has a class they're associated with, and every student has an address they're associated with, and you can have multiple foreign keys for a given table, but only one primary key. And it's just all the things you point to, which themselves point to things.
Thanks.
Yeah, I see people in the chat talking about this thing about modules following a week or not. We're not pushing anything to Monday. It was always supposed to be Monday. It's just a little confusing that it doesn't perfectly line up with weeks. But yeah, the day 1 to day 4 is just how many days we have allotted. It doesn't necessarily line up with the week that you're in. But we get that's a little confusing.
I got a question.
Yeah.
Every time we insert into a table, we're always specifying the ID or the serial primary key. Why don't we just not specify it and let it populate itself?
Yeah, I mean, that's a great point. Does it do that? Because I know that in some things there's auto increment, but does it do that in, is serial enough to do that in PSQL?
I believe, yeah, if you don't specify the serial primary key, it'll just populate itself. But you got to take it out of the, you have it in the values still.
Yes, very good point. So it's not only that I take it out of there, it's that I take it out of all of these.
But I believe it's 0 indexed, so it's going to start at 0 and go up from there. So your foreign keys, which are going to reference that serial primary key, are going to all need to be subtracted by 1 to be the proper number, I believe, since it starts from 0 instead of 1.
Yeah, that
But I
makes,
could be wrong.
well, let's see what happens. So let's just try running this.
Yeah, for me, it creates like a sequence type table for every ID sequence.
Yeah. Yeah, it's doing something in the background with creating some other table. So if I go in here now and I look at these and I say select star from letters, let's see. Yeah, it seems to start the ID at 1.
Oh, okay.
So yeah, you're right. This is a better way to do it where you don't have to be explicit about what things point to. Or sorry, what things have for their IDs.
Yeah,
Yeah.
I was just curious, like yesterday we did that one with the whole seed data sheet, and at the end of the sheet, it had to specify redefining all of the serial primary keys back to the max number of the IDs in every table, because when you actually specify them in your insertions, the serial primary key value gets stuck at 1 because it wasn't assigning it itself, you were assigning it. I don't know if you saw that at the bottom. I don't know who wrote it, but I was just asking, I was just wondering, like, why did they specify it the whole time?
Yeah, I'm not sure. I was just following. SQL is probably the area of web development I'm like least, knowledgeable in, or I've done the least work in. So I was just using those examples to be like, yep, that's how to do it. But I know that every good SQL implementation has this way of like auto incrementing. I guess that's what serial is. So you should just be auto incrementing, because why should you, specify the ID? The ID is just there to be a unique, name for that row. So yeah, let's not name the IDs anymore explicitly.
Is it common practice to create a new insert line every time, or wouldn't you just insert like all the values you want to insert in one line if you have that possibility?
Yeah, can you remind me what is the syntax for that? Like I can just have multiple, like
I think I'm pretty sure it's just you can just go down and it's comma, but you could do it in the same line as well. Just comma what your next value is.
Okay, let's just see, just because it's good to start looking at these docs, because docs are generally hard to read, but if you scroll down, they do have examples. So I see like, yeah, like this is me adding 1. This is adding 1, but being explicit about the fields. And then it looks like right, you just have a comma and multiple rows. So let's try that. We'll go back here and we'll say like, let me see that again, because I feel like I forgot already. So we have values and then in parentheses and then a comma and then in parentheses. Okay. So, right, you're like, it's almost like I want to do this. I'm just adding a bunch at once. And then for these other ones, I might just say like, and SQL doesn't care about spacing. So you can kind of, it doesn't care about white space in the way that, what's called does, Python. So we can do it like this. We can kind of do it however we want. And yeah, let's see this work. Okay, so let's see if this works now. Exit out of here. We're gonna run this again. And that seems to have worked. I see, and I guess that's what those numbers mean, right? So insert 0, 1 means like inserted, I think 0 means like successfully, no error. And then that 1 meant I inserted one thing, whereas this means I inserted 4 things. So yeah, that's the better way to do it, my opinion. So yeah, there's ways you can be explicit and ways you don't have to be explicit. SQL is one of those things that's been around so long. There's just a lot of ways to do the same thing often, and shortcuts when you don't want to be writing the same thing over and over again. And looking at those examples is kind of the best way to go. So when you look at the SQL docs, the PostgreSQL docs, you probably want to skip past all of this because it's hard to understand and just say, let me see some examples. Okay, so now I think we're good to do many to many. Because we've seen one-to-one, this is an example of one-to-one. And we've seen one to many. So for everything in here, there's, you know, something in here, but they're not uniquely tied to each other. But then this is the many to many. This is what things are actually generally like. So, you know, you might have actors, you might have films, and for every actor, they've started multiple films. For every film, there's multiple actors starring in it. And you'll notice here, there's a third table now, because as it turns out, it's kind of the only way to do it. Like if you look at, if we try to do it in Excalidraw, you might try and figure out like, okay, well, if I have, you know, for every course, there could be multiple professors. Well, maybe in courses, I want to have like Professor ID, but then Professor ID2. And then, you know, that doesn't work, as in like, you don't know how many professors are teaching a given course, and you don't know how many courses are taught by a specific professor. So at that point, we'd also probably not only want the course to be aware of all the professors who teach it, but also the professor to be aware of all the courses they teach. And the solution to this is to keep professors, keep courses, and make what's called a bridge table. So that's what this is in the middle here. It's called a bridge table. It's a way of associating the two tables together. So let's see what that looks like. Well, first, many to many, a relationship where a record from table A may be associated with one or more records from table B. So ultimately, what is the example we're going to use? I guess we could just use the example of actors and movies, but I want to make sure I get this right because it's always kind of confusing. One second, is this an example of it? Okay, so I think what we want to do, if we draw it out first, and this is good because I guess we kind of can actually like reason about it. Like we want to create this many to many thing. So I'm just going to recreate our actor and film thing. So we'll come down here and we'll say like, okay, we have actors, and Jason Momoa is an actor and Gal Gadot is an actor. And then we're also going to want something like films. And there we're going to say like, okay, well, let's think of a film that only Jason Momoa is in. We'll say for that one title. So just Aquaman. And then we'll have a film that only Gal Gadot is in, which is Wonder Woman. And then we'll have a film that they're both in, which is Justice League. Okay. Showing what kind of movies I watch. Okay, so right now there's no like constraint thing. It's, actors are just actors, films are just films, and that makes sense. And so now what we're going to do here is make a bridge table, which means we're going to be making a table now. We're actually making a new table. And this table is just going to be for associating things. So we might call it like actor film association. I don't know that that's a great name for it. But we're going to be associating those two things. And so first, everything in this actor films association thing, it still has a row. So it's going to have unique IDs. But then inside, we're going to have two foreign keys in there. One of them is going to be the actor ID. And one of them is going to be the film ID. And then we might have something where we say like, okay, let's get rid of these first. I'm going to say actor ID is going to be Jason Momoa, whose ID is 1, and the film ID is also 1, which is Aquaman. So Aquaman and Jason Momoa are connected. And then so too Gal Gadot. And the fact that these numbers are the same doesn't matter. This could be like 44. It's just, this is the second thing in here. So Gal Gadot is associated with Wonder Woman. Oops. Gal Gadot is associated with Wonder Woman. And it's sort of like this ID is here. And honestly, it's the other way around. This one points here. And let's do it the other way around. This one points here. And then we have kind of the same thing where this one points here and this one points here. But now what about the case where they're in a movie together? Well, we can just have more things in here where I could say, okay, there's this actor with ID 1 and they're in film 3. And there's also an actor with ID 2 and they're also in film 3. And that's what like an association, bridge, whatever you want to call it, table is. It's just a way of saying you need a third table to say many to many. So, and that's actually what we actually want to represent, because every single film is going to have multiple actors in it, and every single actor is going to have worked on multiple films. And we kind of want to be able to, from the actor, look up all the films they've been in, and from the films, look up all the actors in them. Chris.
Yeah, just on like a broad scale, if we're like handling massive amounts of data and then we've got connections all over the place, are we gonna have to build bridges between like all of them, like to get more, like would that be the data analysis type, like we're taking information from all over the place? Or does it kind of automate the whole process to where we're just able to?
So when you're making a schema, you really just want to think about what the nature of the relationships are, not necessarily efficiency. Because if the relationships are that many actors are in many films, that's the relationship you want. And then in terms of, making things efficient, one, the nature of something like PostgreSQL is that you're not supposed to have to know about the implementation. So they're kind of taking care of things being as efficient as possible. But then the other thing is that there's also various kinds of things in databases like sequences, which have been mentioned, which is basically a way of ordering things in a way that makes it more quick to look things up. So let's say that you care about like the alphabetical order of an actor's name. You can create a sequence, and it's a pretty advanced topic. We're not going to cover it. But you can create a sequence that basically has all the rows in an order based on that thing you care about. You know, the letter of their first name. And in that way, anytime you're trying to join things, or anytime you're, you know, only looking up the first 50 or something, it's going to look them up in the right order, so that it's not going to waste time first, you know, getting everybody and then saying, okay, now let me order it by, you know, alphabetical order, and then let me only get the first 50 or something.
Is this kind of how like Facebook does the whole mutual friends thing? Like it's just a database that has everybody linked, and it kind of can.
Yeah, I imagine that's it. Yeah, it's that you probably have, you know, users as one database, and then you have a different thing called, like, you know, user connections or friends, and then that would just link up one user ID to another user ID. So they'd both be referring to the same table. But it would be the case that, like, you know, user 1 is friends with user 44, and then there's another entry, user 1 is friends with user 772. Yeah. But yeah, it's good to think about this stuff, just because, like, the interesting thing about databases is an aspect of it is technology, but a bigger aspect of it is, what are the actual relationships between this data? And you have to know your data. You have to know what you're actually referring to understand that. And so there's this sort of like domain expertise where, like, if I had to make a database and it was about like horse racing, I'd have a lot of questions, because I just don't know that much about horse racing. Like, is there one jockey to every horse, or can a jockey ride multiple horses? Like, I just don't know the rules. And it's just representative of what the actual real world thing is. Okay, so let me just look at the time real quick. So I think we have less time today, a little less, yeah. So what we want to do now, I apologize I wasn't able to give a breakout assignment in this amount of time, but we want to, let's collectively try and actually make this based on what we know. So we're going to kind of update this now. I'll clean this up by taking out the lockers and taking out the letters. We don't need either of those, but just we have multiple actors. Let's say we have Jason Momoa, we have Gal Gadot Momoa, Anthony Hopkins. Let's just do this, what we have right here, as in, we're going to have something called Aquaman. And we're going to have, you know, I can put these all on one line at this point, as in, I'm adding these 3 actors. Maybe I'll just add these, you know, okay, we'll add Ben Affleck. So we have these 3 actors. And then we also have these various films. Maybe it is better to have them on multiple lines so you can see it better. And we're actually going to have to update this, because we don't want lead actor ID. We're just going to have a title for each one. So we'll take out, you know, films is just films right now. I'm probably going to want to keep this data around so I can see it. So I'll just put it here and comment it out. So in this case, I don't even need to do that, because they don't, you know, nothing refers to anything else. So right, I'm inserting into actors, these actors, and I'm inserting to films, these films. And I want to do Aquaman, and I want to do, what is it? Wonder Woman. And what's something that only Ben Affleck is in? You know, has anyone seen The Last Duel? Oh man, that is such a good movie. Everyone like, oh man, and see The Last Duel. But yeah, Ben Affleck is in that, and then the final one will be Justice League, where they're actually all in that. Okay, so if we just have this, and I run this again, let's see if we cannot drop table actors because other objects depend on it. Is that still true? Look, it's not. Oh, right, because there's already a table in there and it's like that. So let's try this. So I think that worked. And now if I run it again, even if I take that out, it should still work. And it doesn't like me inserting things into films because it doesn't exist. Oh, it doesn't like that. Okay, so let's try that again. Okay, now it looks like it worked. And I'm going to go in there and just check. So we're going to select all from actors. That is all of our actors. And then we're going to do the same thing for films. Okay, and now what we want to do is create something just like what we saw in here. So we're trying to do this join table business. And so the first thing I want to do is actually create some kind of association table. And I'll say drop table if exists, and we'll call it actor film association. And now let's create it. Okay, so what should this look like? What's the first thing we want in here that, doesn't really...
ID.
Yeah, and we want an ID just like every other ID. It's going to be serial, so it'll auto increment, and it's a primary key. Great. And now we want two other things, which we're not going to do the constraint yet, but what are they?
Actor ID and film ID.
Yep. Oops, actor ID and film ID. And are there any constraints we want on it? Like what's its type?
Actor ID should be serial.
Yep.
And let's see.
Should it
Couldn't
ever
those be integer or
What?
int? Couldn't those just be integers since they're going to be referenced from the other tables?
Yeah, I believe so. I think, yeah, serial just means an integer that is going to auto increment. So you're probably right that you actually just want it to be integer. I'm not positive, but that should be fine. But yeah, do we want anything else? Like, should every actor do we want to add like unique? Like, can you have an actor twice in this table?
Yes, we can have an actor twice, so we shouldn't add unique, right?
Yeah, exactly. We don't want to add unique. But maybe we want to say like not no, because we're saying, well, it doesn't make sense that you would have an empty actor ID associated with some film. That means that that film has on their list of actors nothing. And probably the same thing for the film ID. Like, there just shouldn't be anything in this table where both of these things aren't filled in. And not no is a pretty standard constraint unless you know that it might not exist. So like with an address, line 1, that should be not null. Line 2, not everyone lives in an apartment, so that can be null. Okay, so we have actor ID. Yep.
Oh, sorry. Would this also be an instance where you use the foreign key since we're referencing the ID from the other table?
Yes. So that's the point where we now want to start writing these constraints. So we're going to say we have some constraints, as in we just said actor ID and film ID are integers, but that means that I can, insert without saying anything else with the constraints. Right now I could say insert into the actor film association. And what am I going to insert into it? Well, I don't want to insert the ID, that'll be automatic, but an actor ID and a film ID, and it's going to have values. And right now, if I don't say anything about constraints, I could just say, 44 and 72, and that's fine because those are both numbers and they're not null. The problem is they don't actually point to things that exist in our database currently, so that doesn't make sense. So the constraint is there to say we actually care that first number refers to a currently existing actor, and that second number refers to a currently existing film.
Do we need to put within actor ID and film ID references the reference tag?
Yeah, that's what we're going to do right now. Like, we're writing the
Okay.
constraints, so we can say, okay, this first constraint, just we're going to follow the pattern. I'll say foreign key We'll just say actor, right? Foreign key actor. And that is a foreign key, so it has to match up to something. And what it matches up to is, well, what it's associated with is this actor ID right here. And that actor ID is going to reference something specifically. And what it references is going to be in the actors table. And what in the actors table? The actors ID. And then I wonder if I have to do a comma here for constraints. Like if I said constraint. So if I'm creating a table, let's look for just examples. Because I know, just trying to figure out if I do comma or what. I guess there's too much for them to cover. But that's maybe a good example of when you would want to actually read this stuff. So this stuff is incredibly hard to read. But we're going to see somewhere here this constraint thing. And it looks like column constraint. Yeah, I don't know if I need a comma or not. I'm going to assume I do. So I'm just going to add another constraint. And that second constraint is going to be called FK foreign key film. And it's going to be for the film ID thing. And it's going to reference film's ID. And I think this should work. But let's see. As in first, even if I don't have this, does it work? As in, is it upset about the commas? So we're going to try that. And it looks like it worked. But there's nothing in there. So if I actually went into P-SQL right now, and I said select star from actor film association, there's nothing in there. So now I'm going to try and insert something in there. And because of how we did our constraints, it should be upset if either of these doesn't actually point to something. So we can try one first where neither is in there. Because we assume this is like 1, 2, 3 for the ideas, 1, 2, 3, 4. So yeah, it doesn't like that. Seems to have more problems than just that knop drop table actors. So I think we want to leave the cascade stuff in there because it can't drop these tables because that other table relies on it. But yeah, we have an error here because it could not insert something into there that violated the foreign key constraints because 44 is not an actors. Well, what if the first thing is an actors? So we're referencing Jason Momoa, but we're referencing a film that's not there. Same issue. It needs to be both because we did both as constraints. So now we'll actually do these where I say, okay, well, Jason Momoa is in Aquaman. And this is going to take care of like our IDs for us. So we're just doing the associations here where I say Jason Momoa is in Aquaman. Gal Gadot is in Wonder Woman. Ben Affleck is in The Last Duel. And then we have a bunch more where we say all of them are in Justice League. So 1 to 3 are all in Justice League. So this should be all the associations. Let's see if it works. I'll do this again. And these are my, associations. And just so I can see, these are my actors. And these are my films. So now let's just say if we wanted to find all the actors for all the movies. Well, let's just say we wanted to say something like, give me every movie that Ben Affleck was in. Let's write that. So I'm going to say select, we'll just say star for now, from, well, I guess I actually care about, it's just the name of the film I want. So I'll say like, film, or I can just say title. So select title from, and how are we going to do this? How are we going to look up all the films associated with a given actor?
Would you use where?
We definitely will use where, but first things first, we want to create a table that has all this information in it. So where do we start?
Films.
We could, I think it doesn't actually matter, but I'm going to start with actor film association because that has all my info. And I'm going to say, starting from there, I'm going to want to join some things. So I'll say, starting from there, I want you to inner join. So we're inner joining actor film association. In fact, I'm going to do this. Sorry, let's do that again. I was gonna do it again because I wanted to actually, like, for now, right now, we're just gonna do the whole thing so that we see. I'm gonna say select star from actor film association. And we want to like update it, little by little. So select star from actor film association, inner join, and what are we inner joining on?
Films.
Sure, we'll start with films. So inner join with films. And what is the relationship? So on, what's the relationship between films and actor film association?
Be the ID.
Yes, so well, not exactly, as in we don't want actor film association's ID. No, I guess, wait. We're saying for actor film association, there's going to be something on it called film ID. So for everything in actor film association, we're going to get its film ID, and we're going to associate that with films.id. So if we just do this, this is what it looks like now, as in we still have the, we're starting from actor film association, we're getting its ID, the actor ID, and the film ID. And then wherever the film ID lines up with what it's calling ID here, that's going to, this part is going to represent the title now. So I'm joining all the information of actor, of film ID and films.id, but I actually want to do that again now. So maybe I can just copy paste that. Oops, can I?
I got a quick question about this.
Mhm.
I mean, I guess this could just be a different way of doing it, but if you did the join where you basically selected the film and name and joined just the actor and film tables and used the actor film association in the where statement, so that's how you actually join them. Like,
Yeah,
would
I
that
like that idea. Let's try that. You're saying, so I'm going to say select star from, still from actor film association, right?
No, maybe select actors dot name comma film dot title, just to be specific.
Yeah.
From actors or from films, either one.
Okay, so we're going to say from actors, right?
And then inner join films on, and then do maybe this won't work. I'm not sure.
I'm not actually sure. If it does work, it's a better way to do it.
On, yeah.
So it might not work because it doesn't, I don't know. We'll see. So we're saying inner join it with films. And our association is that there's this other table called actor film association. And I want to associate its film ID. No, I don't think this is going to work because, we're going to associate its film ID with What are we writing here?
Yeah. I mean, if you did film association dot actors ID, but maybe that wouldn't, I'm not sure. Yeah.
I think you'll have to use two inner joins.
Yeah. Yeah, I think we're gonna go back to the original thing. But it is good to try stuff because that could have worked. So I like, first of all, we're gonna do, select actor. So I'm gonna get out of this and come back in so it's a little cleaner because it's a little hard to see what we're working on right now. So we're gonna get in there and we have those tables and we want to say select actors dot name and films dot title from, and the first thing we'll start with is actor film association. And then from there, I'm going to say inner join. And the inner join is first going to be on films. And we're going to join it such that actor film association dot, what was it? Film ID is identical to films.id. And if we just do that, right, it's not liking it yet because we don't know what actors are, but I guess if we just put star over there, we could at least see. I'll leave star in there for now. That's what that looks like. So the film ID and the ID right next to it match up. But we're actually going to add another line to this. We're going to add another inner join with actors on, same thing, actor underscore film underscore association dot actor ID, and that's equal to actors dot ID. And now if we do that, it's a little harder to tell, but we're associating all the titles, or sorry, we're using that first association table to associate the actor ID with the ID and name and the film ID with the ID and title. So now these match up where the title is Aquaman, the name is Jason Momoa, but then for like Justice League, we have 3 entries with 3 different actors. So at that point, I probably do want to go back to the beginning of this and make it, just have the title and the name. Okay. And now the question is, let's say I wanted to query this further, like this is how I join them all together. But if I want to query them further, how do I say, give me all the actors that were in Justice League?
Where title equals Justice League.
Yep. And at that point, it's almost like, well, why even say the name of the title? But we'll do it based on how this is. But yeah, if I rewrite this now and I go all the way to the front, maybe I'm just getting the name of everyone who is in Justice League. Okay. And then alternatively, I could say, what are all the movies Ben Affleck is in? How would we do that?
You could use his actor ID, just like we could have used the film ID right there too, probably. But
yeah. And we could have used his ID if we remember it, but if we're like querying this ourselves, maybe we don't know his ID. So we're saying, there's this person named Ben Affleck. I know that's a unique actor name, and I want to get all the films he was in. So in this case, I don't want to see his name multiple times. I want to say, select, title from, yeah. And now we see the 2 movies he was in. So it definitely can look a little complex, but the thing is to do it in steps. So you see how you're starting from one table, using it to sort of grow that table by, filling in what that, foreign key relates to. You keep doing that until you have all the data in there. And then you can query it however you specifically want to query it.
I have a question just on with the inner joins, like even though you have 2, you only have like 1 column that shows up.
Well, if I only have 1 column that shows up because of what's at the very front of that select.
Okay.
So if I
join always added on, like it just seems like it would add on like another column or for some reason.
It does. I mean, it adds up. It adds on everything from one table to another. So this looks pretty ugly, but this is all the things for Ben Affleck. But because I didn't, specify the columns I wanted, that first ID represents the Actor Film Association ID, then its Actor ID and Film ID, and then it added on the ID and title from film, but such that these line up. And then it added on the ID and name from actors such that these and these line up. And then this is everything it has, but that's probably not, what we want to see. Is that helpful or?
Yeah, that makes sense. I guess. Yeah, that makes more sense. Just seeing like you're just pulling that one specific element that you just want the titles, whereas like everything's still there. You're just not getting that.
It's good to see it like in order. Where like first we're getting just this, and then we're getting just this. So we actually started with that first thing, and then we said we're joining something. So we're getting another table. And then we're associating something from one table with the other. And by default, everything gets added there. So even ID, we have ID twice because the first ID came from one table, the second ID came from another. But there's that association. And then, of course, finally, we have all of them. And it is creating this before it like looks specifically for things with Ben Affleck. And then finally, we would narrow it down just to Ben Affleck. And then if we did it this way, finally, we would say, oh, we just want, the name and the title in that order.
I have a quick question about the inner join too. So when you use inner join, is this actually changing the table that you're comparing it with, or is that just a temporary thing?
Yeah, great question. It is not changing the underlying table, it's temporary. So every time you run one of these, like even just select star from Film Association, that's essentially creating it's taking everything from that table, that's the real table, and it creates a new table based on what you say. So if you say this, it'll look identical, but if you said you just want the actor IDs, what it produces is a temporary table. And for all of these things, it's producing a temporary table and then another temporary table. So when you're doing stuff with select, you're not altering the underlying thing at all.
If you did want to save that table, you got to do something with the current view, right? It's like the current view command or something like that, I think.
You're saying if I wanted to do what?
If you did want to save like your query into a table, I think you have to like save the current view or something like that.
Oh yeah, I don't know too much about that. There could be something like that. Yeah, I would say for now, just like, because we eventually get into using, Python to work with SQL, and then this thing called an ORM, which lets you like think of SQL in terms of objects instead of raw queries. For now, there's no need to become like a SQL expert. And it is cumbersome to do it this way, but you really do want to understand what's happening at the lowest level, because pretty soon you add up to layers where you don't see that lower level anymore. So it's good to know that you could always go into PSQL and type these commands and find out exactly the like truth of things.
But they use this in finance as well. Like maybe somebody's getting paid here, but they want to take data from different areas and make a formula to determine how they're going to pay somebody or something like that.
Yeah, I mean, it doesn't really matter the industry. Everyone's using databases. The real thing is like, if you're doing some like complex calculation, you'll probably be using a programming language for that. But the idea is that the database represents the source of truth. Because when that program stops running, it stops running. It's only things you either save to or read from the database that live forever. And that's why, like, in a production system, it's very important that your SQL stuff is right. And that, you have these separate layers of, like, your development environment, your test environment, your production environment. Because, like, if I work at a bank and I want to test something out, well, I can test something out with, like, made up accounts. But in production, if someone has a certain amount of money and I mess up and I overwrite it, there's no going back, because that's the source of truth. There's no history saying so you have to be very careful with databases are your source of truth. So when you update that source of truth, you really hope you're doing what you think you're doing. I'm sure in, like, companies, they haven't figured out where there's always, like, a backup. Like, they can't actually overwrite things outright.
So sorry. Just curious. So in that case, would like they be pulling like almost like GitHub, like pulling like a separate branch that they like maybe mess with the information on and then keep the main source of truth somewhere separate on the hard database?
Yeah, that's what it is essentially. They're not using GitHub necessarily in, like, branches, but basically, let's say they're using AWS and that's where their databases live. Just, Amazon owns the physical hardware and they just run it. So they own multiple, databases. They don't just own one and do everything there. They own one and they call it development, and they own one and they call it test, and they own one and they call it production. And they have them linked up to each other so that if something passes dev, then it can be pushed to test. And only if you pass some tests do you then push it to production. And once it's in production, any changes that happen are real changes. So if you accidentally add $1 million to someone's account, they have every right to say, well, that is how much money I have now. I mean, I don't know if this has ever happened, but kind of with all things in programming, once you get to the real world, it gets complex very fast because people have to come up with all these systems for, like, security and just, like, making sure there's, like, always some backup somewhere. But in terms of the fundamentals, like, there's too much of a distance between understanding the fundamentals, which is what we're teaching you, and, like, the practical. It's the reason why, as a junior developer, you'll never have this root level access. And in truth, most developers don't. It's only the person who really has to that has that level of access. Yep, that's all I have for you. We're technically done now.
Could you do another prompt, but using a different type of join, like a left or right or outer join?
Sure, yeah.
How that would work.
The point, in order to see joins do interesting things, we need to start adding null. So let's say we have this actor and film thing, and let's say we have a situation where we say, okay, like, actor ID can be null or film ID can be null, because you have some films. I don't know. I mean, it's not clear why you would have this, but we have a situation in which we're associating actors and films, but sometimes you have an actor associated with no films. Let's say, like, they're in it. Yeah, I'm not sure why we would have this as the actor film association, but if this is the case, then we still have these three. So we have actors and we have films, but then I could start saying things like, okay, well, this actor, Jason Momoa, he also points to null. So this actor, Jason Momoa, he has an association where there's no film. And then we might say there is an actor, or, like, there's a film, like, I mean, I would prefer to come up with a better example, but just for now, we'll say, like, okay, well, there's also null and Justice League. So somehow there's, like, an unnamed person on the credits of Justice League. So what we're going to do right now, because we remove those not null associations, I wonder if it'll still break because of the foreign key constraint. We'll try it. So that seemed to work, and let's go in there and see what it looks like. So we're going to select all from the Actor Film Association, and you'll see there's some nulls in there, right? So the nulls are going to matter when we do joins, where if I go back to that original thing I have where I say like, okay, I want the name and the title. Let's just say we want the name and the title for, you know, every film to every actor. So because I'm saying inner join on both of these, it's going to give me what I expect, which is just name on the left, title on the right. They're always filled in. But if I go into here, I could say, okay, well, the first thing I'm doing is taking the Actor Film Association, and then I'm actually going to delete stuff so you can see it. First, I'm taking, let's just take everything from Actor Film Association. Okay, and now I'm going to say take everything from Actor Film Association, and then we're going to say not inner join, but let's say we do. I get them pretty confused. I think we're going to say left join because we're saying if nothing is in the actor ID, I still want it to show up on the right. We might want to look this up. So in terms of joins,
I think you're right. If you use left join, the left table or the first table you have in there is going to be the one that still shows all the values.
Yeah, which is why the order would sometimes matter in terms of whether you're saying Actor Film Association or, you know, actors first or whatever. So if I say left join, I'm saying include, I think I want to actually look this up. I only understand in terms of the Venn diagram. Join table Venn. Okay, so this first one I'm saying get everything from table A and then left join it to table B, meaning that as long as the thing is in A, I don't care if it's in B or not. So I think actually what I want there is maybe a right join. I don't know. I would have to see to see. So let's say I'll just say left join. And what am I left joining? I'm left joining for, let's just do films first. And we're doing on, and it's going to be the same thing where I say Actor Film Association. I'm pretty sure I should end soon because I think we have something right over this and I want to give you guys a little break. So yeah, we'll just do this last thing. Actor Film Association dot film ID is going to be associated with films dot ID. So let's just see what this does. Okay, we did a left join, and what that means is that it took all the film IDs on the left and it joined them to films.id, but if there was a blank, we kept it in there. And if I did a right join, it wouldn't do that because if something wasn't on the left, it's not going to put it in there. But in this case, it would still put something in there if the thing on the right, the actual film title was like null. So, you know, we would just write inner join instead. But if I do this left join thing, that's going to have all those associations. And then I could do that again, where I would say left join for actors. And we're going to be associating the actor ID with actors. And you'll see we have even more now where the actor ID is empty and that points to another thing. And that could be something maybe you would want in some cases, but the reason why it doesn't quite work for us is that now if we said like we just want the title and the name associating every actor and every film, we have this thing where it's like, okay, we have Jason Momoa starring in Aquaman, we have Jason Momoa starring in Nothing, we also have nobody starring in Justice League. So it doesn't really make sense for this example, but that's the whole point of like understanding your data, because sometimes you want a left join or a right join or any of these other, you know, approaches because your data is like that, where even if that, you know, even if it's missing on the first table, you still want to see it. You still want to associate it and see, you know, you want to see that non-title film Jason Momoa is associated with. It's hard to explain without coming up with a really good example. But essentially, your most common cases are going to be an inner join, where it's only when they're both not null, or something like a full outer join, where you don't care if either is null. You just want to, you know, put the null entry in there because for whatever reason, that's what you want. Yeah, so that is time for us. I'm Francisco, are you here? Are we jumping right into this, or is it a separate meeting?
I am here. Yes, we're supposed to do retro. If you want, we could take like a 10-minute break, and then right after that.
Yeah, let's do a short break. Yeah, and then I'll get off for a second so I can download the video.
Okay, awesome.
Cool. So 10-minute break. Okay.